Good day. Good day, students. Now we continue our lectures in physics. And today we'll talk about electric properties of tissues and bodies. Characteristic of electric current. The electric phenomena in a human organism are connected with the passing of currents in tissues of human organism, being in most cases the mediums well conducting the electric current, except for skin and bone tissues. The basic characteristics of currents are the current strength, I, and the current density, G. Electric current is an ordered motion of electric charges. Electric current has properties of thermal, chemical, and magnetic action. Current strength is determined by the ratio of charge quantity dq, which is carried through the cross-section of conductor to the time interval dt required to carry this charge. Look at this expression. If for any equal time intervals the equal quantities of electric charge are carried, then the current will be called continuous or direct. We write down I is equal, it's a ratio Q divided by T. I in a C system has a unit ampere, and the Q has a unit coulomb. The current density is the ratio of current strength passing through the cross section of conductor to the area over this section S. And this I divided by S. The unit of the current density is ampere per square meter. Ohm's law. In most cases, at constant temperature, the ratio of voltage at the end of conductor U to quantity of current I in it is a constant. R is equal U divided by I. Quantity R is called conductor resistance. The unit of resistance is ohm. Resistance of uniform conductor with unchangeable section is in direct proportional to its length L and is inversely proportional to the area of cross section S. And we can see this expression where rho is a specific resistance, and this rho specific resistance. The unit of specific resistance is ohm meter, and the quantity sigma reciprocal to specific resistance is called specific conductivity. And unit for conductivity it's ohm in power minus 1 or Siemens per meter. Siemens per meter. And then look at this table. this conductivity of biological tissues and fluids. Conductors are substances which have the free charges capable to move under the influence of electric field. And examples: blood, plasma, lymph, intercellular liquid, spinal liquid, cytoplasm. Dielectrics isolators are substances which have no free charges, therefore do not spend an electric current. Example: a dry skin, sinus, bone tissue, cellular membrane. Biological tissue is of a rather heterogeneous conductivity. It has areas with high conductivity and low conductivity that alternate in a compilated manner. And look at this table. In the first column, we can see tissues, and in the first column, you can see a specific resistance of these tissues. Electric conductivity measurement conductometry is widely used in a study of processes occurred in leaf cells and tissues at the time of physiological change of state as a result of action of particular chemical substances and pathologic processes. Considering dynamics of change of electric resistance of skin, we can judge of the so-called skin galvanic reactions, which reflect emotions, tiredness, and other states of organism. Electric resistance for the determination of active points is used in reflex therapy. Year in year, arsenal of researches of electric properties of biological tissue has been growing steadily. In an organism, there are no such a system which would be similar to inductance coils. Therefore, tissue of the person do not possess inductance resistance. And look at this effect, this table, this effect of current strength. And the first column we can see the current strength, and in the second column you can see effects. And in the range from 0.1 and 1 milliampere, it's no effects. And from 1 to 1.5 milliampere, irritating action, and 1 milliampere is a perceptible current threshold. And from 1.5 to 2 milliampere is a loss of perceptibility. And from 2 to 16 milliampere, it's a pain and it's a contraction of muscles. And from 16 to 20 milliampere, it's motionless current with a higher quantity of which make it possible for a human being to get free from electrodes. And from 20 to 100 milliamperes is a respiratory paralysis. And from 0.1 to 3 ampere is a lethal ventricular fibrillation, and more than 3 ampere is a cardiac arrest, severe flash burn. And for human in a different condition is very dangerous. The current strength just ampere, but not a milliampere, but just ampere. It's very dangerous. And then alternating current is a current periodically changing on value and direction. The most widespread is the sine wave alternating current, which instant value varies in time under the law of sine or cos. Let's consider physical basis of reception of alternating current and the principle of device of generator. Let in the field of a constant magnet, it's B is constant. The constant magnet rotates the conducting framework with a constant angular speed omega. Then instant value of the stream connected with a contour will be equal to its phi, the magnetic flux. And in a C system, the unit of magnetic flux is a Weber. And look at this expression. Where B, it's induction of a magnetic field, B, and S is the area. Area limited by the contour, and B, induction of the magnetic field, and this phi is a product omega and t, this angular velocity product to time. Phi is an angle of rotation of the contour and counted from its initial position when S is perpendicular B. According to the law of Faraday, in the framework arises EMF of induction. EMF is an electromotive force. And electromotive force E, look at this first expression, where the product BS and omega, it's a maximum peak of the EMF of induction. And E is equal to E maximum and sin omega t. Hence, if in the uniform magnetic field rotates the conducting contour, in it there a variable EMF changing under the law of sin in regular intervals. This electromotive force creates a sine wave alternating current in the contour. And look at this expression for alternating current, where the R is the resistance of the contour and of the electric current, in which the electric current by means of brushes sliding on rings. These brushes, look at the picture, brushes and these rings is allocated and this maximum current is a peak value of an alternating current. The omega is a circular frequency, and this phi or omega product T is a phase of current. The alternating current also is characterized by period and frequency, and this omega is equal to pi nu. Nu is the frequency, and omega is equal to pi divided by period. Graphically, value electromotive force and an alternating current will be represented by two sinusoids. Values change in identical phases. The considerate way of reception of alternating current underlies at the heart of a device of the industrial generator of alternating current. In industrial generators, the magnetic field is created by a powerful electromagnet. The rotating contour consists from N coils of the wire which has been relayed up of the ferromagnet core. Therefore, electromotive force excited in such generator will be equal E is equal B S N omega and sin omega t. For the characteristic of an alternating current, the concept of working or root mean square value of current is entered. The effective value of alternating current is defined as that steady current which would develop the same quantity of heat at the same time in the same resistance as done by direct current. And look at this expression. The device is included in a circuit of alternating current. Ammeter and voltmeter show effective values of a current and a voltage. When it is stated that the alternating current potential difference between the supply means is 220 volts. This means the effective potential difference is 220 volts, and the peak value is 311 volts. Various kind of electric resistance in a current of alternating current, in a circuit of alternating current. And first of all, talk about active resistance in a circuit of alternating current. Look at this picture. Resistance R in a circuit of alternating current is called the active. Since at a passage of a current in it there is an irreversible loss of energy. At a presence in a circuit only R, a voltage is in voltage is U is equal U0 sin omega t. The current and the voltage coincide on a phase. The graph of current and voltage and also the vectors diagram of amplitude of a current and the voltage are shown in this picture. This current and this voltage, and we can see a vector diagram is a not a shift phase, and these vectors for current and for voltage goes round with omega, and then we can see inductive resistance or inductance in a circuit of alternating current. And let's consider a case where the circuit contains only the coil of inductance with a small resistance. And significant inductance, we can note it L. It's a big letter. Let in the circuit there is an alternating current. It is I is equal I0 sin omega t. And it cases in the coil electromotive force of self-induction EL, which at any moment is opposite to and close to a voltage UL and counterbalance it. And EL is equal minus L and dI divided by dt, and we can get a voltage for coil. It is, look at this picture, this expression, and U0L, it's a product of three values, I0, omega, and L. Is peak value of the voltage. From this formula follows that I0 is voltage divided by omega L, and this omega L is inductive resistance of the coil. And it only induced resistance in a circuit clarification is not presence, as R is equal 0. The role of inductance is reduced to accumulation of magnetic field energy and returning of this energy back to a cell. There is a periodic energy transfer from a current source to a circuit, and from the circuit to the current source. In ideal case, a loss free of energy. RL is this inductive resistance of the coil increases with the growth of frequency of alternating current. Dimensions of inductive resistance is ohm. For a circuit with inductance in which the voltage outstrips a current on a 90-degree wave, and the vector diagram submitting in this picture. And you can see this angle between current and voltage, and two vectors goes around with velocity omega, and we can see this shift angle is 90 degree between two scenes for current and for voltage. And now we can talk about a capacitance in a circuit of alternating current. Let's consider a case when the condenser C is included in a circuit. By resistance and inductance of bringing wires is possible to neglect. Let the current in the circuit change under the law I is equal I0 sinus omega t. The voltage on plates of the condenser can be presented by the following formula. In this U C is equal Q divided by C. And current in the circuit, it is I is equal dq divided by dt. And we can get expression to the q. It's I 0 divided by omega cos omega t. Then we can rewrite this expression, and we get for voltage is U0 sin omega t minus 90 degree. And we can peak value of current is I0 is U divided by this resistance of condenser, and resistance of condenser. Look at this expression. It is 1 divided by omega c. It's a C, it's a capacitance. It decreases with growth of frequency. RC has a dimension of ohm, and in a circuit with only capacitance with voltage and close to plates of the condenser lags behind on phase of current on 90 degree. It is reflected on the wave and vector diagram on this picture. In the circuit with the condenser, clarification is not present, is ohmic resistance of conductors equal to null. The role of capacity is reduced to accumulate of electrical field energy of the condenser and returning of this energy back to a current source. There is a periodic energy transfer from a current source to the circuit and from the circuit to the current source, in ideal case loss-free of energy. And look at total resistance, impedance, in a circuit of alternating current, resistance of voltage. And this circuit, series resonance circuit, consists of these three elements. resistance coil and condenser. And let's consider a circuit consisting from RL and C joined in series. The current is equal I0 sin omega t. We shall define how the voltage will change. The sum of falling of voltage on RL and C is equal to the enclosed voltage. And we can write down this U0, it's voltage of resistance, and voltage of a coil, and voltage of condenser. And owing to presence of a phase difference between a coil and a condenser, between voltage coil and voltage condenser, and the current in a resistance is in identical phase with the current. This voltage can be put vectorally and under theorem of Pythagoras, enclosed voltage is equal, and U0. Look at this triangle, and U0 is this expression where Z is known as a total resistance, or other way, impedance. And this active resistance in this reactive resistance. The law of Ohm for the given circuit will be written down in this form. This expression demonstrates Ohm's law for alternating current. The difference of phases between the current and the voltage is defined by the angle theta between vectors U0 and UR. Then from diagram we can see that is tangent theta is equal coil resistance minus condenser resistance divided by R is active resistance. From the formula for Z for impedance follows that then closer on the value omega L, and 1 divided by omega C, the less impedance Z, and there is more current in this circuit. At L is equal RC when resistance coil is equal to resistance condenser. Total resistance Z, the impedance, is equal to R. And the current achieved of greatest value caused only by active resistance. This phenomena is known as electric resonance, which is provided by selection corresponding L and C. Resonance in the series circuit is called a resonance of voltage, as this occurs mutual indemnification of voltage UL and UC. Each of UL and UC can signification exceed the voltage U unclosed to the circuit. And talk about total resistance, impedance of tissues of human organism. Using of the method of electroconductivity in medicine. At work with a biological object found that on high frequencies, 10 in power of 7 Hz, electroconductivity is much higher than for the low frequencies. At increase of frequency, electrical conductivity increases up to some maximum value. On the picture is resulted a curves of dependence of resistance of muscles from a frequency, curves of dispersion. The zone of dispersion of electroconductivity usually varies in the interval 10 in power of 2 to 10 in power of 8 Hz. The dispersion of electric conductivity of living tissue on low frequencies is connected with polarization, but with increase of frequency, the polarizing phenomena will decrease. For dampened tissue, the sleepiness of dispersion decreases, and for dead tissues, the graph is represented by a line parallel to the axis of frequency, the logarithm of frequency. Steepness of dispersion expressed by the ratio of value of the resistance measured on the low frequency to the value of the resistance measured on high frequency. If two resistances are measured on different frequency under the same conditions, the ratio between them appear to constant for a normal conduction condition of the given tissue. Usually choose for measurement on frequency 10 in power of 4 Hz and 10 in power of 6 Hz. As a frequency of 10 in power of 6 Hz is in many cases is observed maximal electroconductivity, and for frequency of 10 in power 4 Hz is observed change of curves dispersion. This K is equal Z in 10 in power of 4 divided by Z 10 in power of 6. For a tissue, the specified coefficient aspires to 1. Explaining passage of alternating electric current through biological objects, recognize that resistance of living cells consists from ohmic and capacitive resistance. Inductive elements in biological objects are absent. Tissue of human organism will consist of cells washed by tissue liquid. Such elements represent two mediums with good conductivity of current divided by a badly conducting layer of a cellular membrane. Such system has electric capacity. In tissues, there are microscopic formation consisting of various connecting mediums and partitions on which both parties there are tissues well conducting electric current. It gives to tissue capacitor properties also. Ohmic resistance does not depend from frequency, and the capacitor resistance considerably decreases with increase of frequency, and its result to increase of conductivity of all capacitance resistance system. For connection in a series of resistance and condenser, total resistance is defined under the formula is Z is equal and the root of active resistance in square and capacitor condenser resistor is square. Presence at biological system of capacities proves by the presence of shift of phases between a current and a voltage. The angle of shift of phases is defined by a ratio between capacitor and the ohmic resistance. For biological systems, the big value of this angle is characteristic. It shows that the share of a capacitance in tissue is great. Let's result examples of value of angles of shift of the phases received on frequency 10 in power of 3 Hz. Human skin is 55 degree, muscles of rabbit 65 degree, nerves of frog 64 degree. Taking into account that the total value of resistance impedance of a living object is submitted only by the geometrical sum of ohmic and the capacitor resistance for characteristic of conductivity of current by living tissue, use the equivalent circuit. To such combination of ohmic resistance and capacity, which in some approximation can model electric parameters of tissue. Elementary of them are circuit with a connection of resistance and capacitor in series. It's here. This circuit is the first. This is first, and independence. Impedance depends on a circular frequency. And with a this parallel connection of this element in a circuit 2. But this element circuit cannot be completely applicable for living cells. Is follows from the graph of dependence of Z from omega for the first circuit. It's B. If omega tends to 0, the resistance tends to infinity, then contradicts to experience. From the graph of dependence of Z from omega for the second circuit is visible, and that omega tends to infinity, impedance tends to 0. That on experience does not prove to be true. The circuit combining first two circuits is the most successful. One of them is represented on figure 3. Look at this. On this circuit are RK1 and RK2 are resistance of skin, and RT is the resistance of tissue, and C1, C2, and C3 are capacity shunting this resistance. It also shows the direction of alternating current in one of the half cycles. Resistance RK1 and RK2 are very great, and alternating current through them does not pass. On dependence B, the graph of dependence Z from omega for this current is given that corresponds to the scaled data. There are other complex equivalent circuits, however, any of them in the accuracy cannot reproduce the law inherent to complex biological system. On this picture presented the graph of the frequency dependence of impedance of muscular tissue. For compactness, the curves are built in logarithmic coordinates from the graph to singularities of this association are visible. And the smoothly varying decrease of impedance with increase of frequency, and second, present of three areas of frequencies in which the deviation from a common course of dependence occurs. Z is not various. They have been called accordingly is the field alpha, beta, and gamma dispersions of impedance. Presence of this field of impedance speaks that with increase of frequency of alternating electric field in appearance of polarization participate different structures of biological tissues. At low frequencies, all structures react to change of a field, alpha dispersion. With increase of frequency, large molecules, dipoles of organic junctions, and molecules of water, beta dispersion react. And at the most major frequency, molecules of water react only the gamma dispersion. With the increase of frequency of an electric field of ever less structures will react to a change of this field. The capacity of tissues decreases that leads to increase of impedance Z. Hence, at a common trends to decreasing of impedance that are filled with a smaller decreasing of impedance. The method of electroconductivity on alternating current is in living tissues and cells is used in biological researches and medicine for estimation of pathological processes. For example, at measurements in the field of low frequencies is observed increase of resistance of tissue and inflammation at the first stage. Current of low frequency goes mainly through intercellular spaces. Inflammation as a result of swelling and of cells and the section of intercellular intervals decreases that attract increase of ohmic resistance, while the capacity of cells at early stage of inflammation remains constant. In diagnostics, it is used as the method of measurement of the angle of shift phase at some decreases or at physiological changes. A perceivable change of the angle of shift of phases is found out. For characteristic of physiological condition of tissue is used value of steepness of dispersion. This criterion applied, for example, at estimation of viability of the tissues intended for transplantation. And talk about electrophysiotherapy and electrosurgery. Electrical current effects on tissues depend on current type. The following currents can influence on tissue: direct, pulse, and alternating ones. A current strength and a current density are direct current characteristic. Current strength in tissues is defined by an applied voltage and tissue-specific resistance or specific conductance. When direct current is flowing through tissues, ions in the tissues flow rapidly in one and the same direction. Positive ions shift to one side and accumulate in particular parts of tissue. Negative ions shift to opposite side and accumulate in other parts of tissue. So the main mechanism of direct current effect on biological tissues is change of ion concentrations in different parts of tissue in comparison with common concentration. It is necessary to note the direct current flowing in tissues can significantly decrease in time even if voltage is constant. It is related to that fact that ion shift and ion concentration in different parts of human body changes. Due to ion shifting, the ions form an electric field in tissues. This opposite field partly compensates an external field. Tissue polarization electromotive force is induced and it reduces current. And to talk about medical method based on use of direct current. And it is a galvanization. It's a galvanization. Voltage from 60 to 80 volts is used for galvanization. In this method, current density must not exceed, but current density not exceed 1 ampere per meter in square. An alternative current rectifier is used as a device for galvanization. It enables to regulate output voltage and control induced current. Electrodes made of sheet lead of foil are commonly used to get current to a patient. Hydrophilic layer wet with water or physiological solution are placed between a patient's skin and the electrodes. The application of layer reduces skin resistance due to skin moisturizing. It also improves the contact between the electrodes and the human body. The application of layer protects patient's skin from being burnt by the products of sodium chloride electrolysis, during which alkalis are deposited on cathode and acid are deposited on anode. Human body reacts on the change of concentration of different ions in tissues where direct current flows through them. It in particular stimulates circulation of the blood and the lymph, as well as metabolic processes in cells. Besides nerves and muscular cells, excitability increases under cathode and decreases under anode. Nerve cell excitability domination under anode cases in particularly local analgesia effects. Galvanization can be used in treatment of some nervous decreases, bronchial asthma, and etc. Medical electrophoresis is a method of treatment when direct current is used for introducing medical substances through skin or mucous membranes. Medical electrophoresis is performed similar to galvanization, but one of hydrophilic layer is wet, not with water, but with a certain medical solution. Introduction of medical substances by means of electrophoresis is possible if medical dissolving in water from ions. In this case, anions are introduced to a patient when a layer under cathode is wet with a medical solution. Cautions are introduced to patient when a layer under anode is wet with a medical solution. Electrophoresis method of introducing medicines has a lot of advantages in comparison with other methods. Electrophoresis does not hurt skin and ensures local effect in a required place. The medicine is introduced in ion form, and it's ions that makes a therapeutic effect. The medicine introduced by means of electrophoresis accumulates in hypodermic cellular tissue and is washed out from it slowly. That ensures prolonged uninterrupted medicine action in a pathological center. Electrophoresis can be used for diagnostic purposes, for example, for plasma protein fraction separation and detection. That is highly informative for diagnostic of a number of decreases. Talk about alternating current effect on biological tissue. Alternating current is characterized by voltage, current strength, amplitudes of these quantities, frequency, and phase. Frequency and quantities referred to frequency, cycle frequency, and period. Dependency on frequency. Different effects of alternating current on tissues can be apparent. If frequencies are low, alternating current similar to pulse current caused irritation of excitable tissues. If frequency are high, when charges particles shift is not great in tissues, thermal effect takes place. Tissue heating as a result of current flowing. Alternating current, like pulse current, causes irritation in excitable tissues only excitable tissues only then when current is greater or equal to threshold current. Threshold current grows as alternating current frequency grows. Medical method based on use of alternating current. Diathermy. Diathermy is based on a phenomena of heating when alternating current flows through tissues. There are therapeutic diathermy and surgical diathermy, which in its turn is divided into diathermotomy and diathermocoagulation. When a diathermy is used, a specific heat power of current flowing through the tissue is defined by the formula. Q is equal to current density square product to resistivity of tissue through which current flows. An alternating current of 1 megahertz frequency and 1 or 1.5 ampere is used for therapeutic diathermy. The current is applied to a patient with the help of metal electrodes that have a sufficiently great area of contact with the patient's body. The electrodes must be tightly attached to patient's body. It's evident amount of heat is evolved. That results in useless evaluation of a great amount of heat in the skin. Besides, therapeutic diathermy is not a safe method if the contact between an electrode and the skin surface is lost and the contact area decreases. It results in current density increase and local heating. It can cause skin burn instead of skin heating. Because of this problem, therapeutic diathermy is rarely used in our time. The current of 10 megahertz frequency is used in electrical surgery. 2 electrodes are applied for it. 1 electrode have a great area of contact with the patient's body and the other electrode is sharp. In the very place where a sharp electrode touches patient's body, current reaches great density and great heat power occurs. During diathermocoagulation, blood vessels due to the effect of coagulation. During diathermotomy, a sharp electrode acts as an electrical knife, which cuts tissue by burning it. Diathermotomy is good for a surgeon, as this method is particularly bloodless because the vessels are cut and sealed simultaneously. At the same time, such cuts are helped up slowly than the usual cuts made by a common scalpel. Local sonvalization. When a certain method used current applied, the current affecting the patient is alternating and a pulse at the same time. So at local sonvalization, the alternating current of 100 or 400 kilohertz frequency acts at a patient, but the current is applied to him like pulses with a repetition frequency of 50 hertz. In this case, the voltage is 10 kilovolts. The current is applied to a patient with the help of electrode having a very great resistance. When such electrode is approaching to a patient's skin, as peak occurs, the current starts to flow. However, when current flows at a glass electrode, a great voltage reduces that result in a sharp decrease of voltage between the skin and the electrode. When a discharge goes down, the current flowing stops and great voltage occurs again between the skin and the electrode. That leads to the next discharge again, etc. A local dorsonvalization gets a local irritation to nerves endings in the skin that stimulates the local circulation of the blood in the skin and causes a lot of other positive results. And read more about medical method in PDF file. And now we will talk about a magnetic field. Magnetic field. Magnetic field in vacuum and its characteristics. The source of a microscopic magnetic field is a magnetized body, conductors with a current and movable electric charges. The nature of them source is unified magnetic field appear as a result of motion of charges, microparticles, electrons, photons, ions. Magnetic field may be determined by the action on movable electric charges of magnetic permanent. Magnetic field is characterized by a vector of magnetic field density, magnetic induction, B. Magnetic induction at some field point is equal to the ratio of maximum torque acting on the test frame with current at the given point to frame magnetic moment. And look at this first expression. Magnetic field intensity, it's H, is another quantity characteristic of magnetic field. Magnetic field intensity, unlike B, does not depend on magnetic properties. In vacuum, vectors and B are unidirectional and connected with each other by the ratio. And the ratio between B and H. Mu 0 is equal 4 pi product to 10 in power of minus 7 is an absolute magnetic permeability of vacuum. It's a magnetic constant. Unit of magnetic field intensity in the C system, it's ampere by meter. Vector flux of magnetic induction and magnetic flux is d phi. Look at this expression, d phi, through elementary area, element ds. of open surface. S is the quantity, and we get dF is equal B ds cos alpha. Alpha is the angle between normal line to the area element and vector B. Magnetic flux flux unit in C system is 1 Weber. Magnetic flux generated by magnetic field with induction 1 Tesla that goes through flat surface 1 meter in square placed perpendicular to vector B. Biot-Savart-Laplace law. Magnetic field intensity H generated by direct current may be defined using the law experimentally opened by French physicists Biot and Savart in 1920 and formulated in general form by Laplace. Let's mark in a conductor with a current a rather small part dl, which may be considered as a vector directed in the same way as a current. Look at this picture of the dl, this dl, it's a vector. The product IDL is a current element. And look at this, you can see current element IDL. It's a radius vector R at the investigate point P under this radius vector R and this point A. Generated by the given current element is equal to, and look this expression, dH. Alpha is the angle between vector dl and r. Coefficient k depend on the chosen unit system. K is equal mu 0 divided by 4 pi. In a C system, K is equal 1 divided by 4 pi. Force action of magnetic field on conductor with the current may be defined in accordance with the Ampere's law. Look at this expression where alpha is the angle created by vector dl and b. It's this dl and b. Talk about electromagnetic method for measurement of blood velocity. Blood velocity. Okay. We have seen effect of a magnetic field on free moving charges. The magnetic field also affects charges moving in a conductor. One result is a Hall effect, which has important implication and applications. Figure shows what happens to charges moving through a conductor in a magnetic field. The field is perpendicular to the electron drift velocity and to the width of the conductor. The creation of a voltage across a current carrying conductor by a magnetic field is known as a Hall effect. After Edwin Hall, the American physicist who discovered it in 1879. There are a lot of methods for measurement of blood velocity in vessels of blood circulation system. One of them is based on the action of magnetic field on movable charges. Blood contains considerable quantity of electric charges, iron concentration, sodium, and chlorine. If we place artery of d diameter between magnet poles, the Lorentz force will influence univalent ions. Under its action, ions of different sign move towards opposite artery walls and create potential differences along the vertical line. Electric field with a strength is a Hall effect. Charge concentration on the opposite artery walls will increase until force on the field generated by them compensates Lorentz force. From the equal F and F, this electric, we may determine ion flow velocity and according blood flow speed. And this formula write down in this expression for velocity. Hence, blood flow velocity is in direct proportional to voltage. Potential different at Hall effects, which occurs across the artery if it is a bright intermagnetic field. Biocurrents appeared in organism is a source of weak magnetic field, which sometimes may be registered. This, for example, there is a diagnostic approach called magnetocardiography. Registration of magnetic field change of heart during a cardiac cycle. Advantage of such approach is the absence of electrical constant that creates necessary prerequisites for remote diagnostics. Primary physical processes are in the basis of action of magnetic field on biological objects. First and foremost, they include change of concentration of molecules in heterogeneous medium and action of Lorentz force in ion moving together with biological fluids. Hall effects that appears in magnetic fields at the time of spread of electric impulse. Different kinetic processes. It should be stressed that biology is still in the making, and the physical nature of action of magnetic field on biological object has not been sufficiently studied up to now. And that's all. Thank you for your attention and your homework. Read a PDF lecture and take the test after lecture in 2 weeks. I will open the test for you tomorrow, and I will open a lecture at the PDF format today. Thank you for your attention. Goodbye.